quadratic equations, we're going to talk about an equation with the highest degree of 2. Okay. We're going to learn 3 different ways to solve them. Some of them can be used for multiple problems. Some problems you can only use one. Some problems it's easier to use one than the other. Well, these are the 3 we'll look at. First one is going to be factoring, the age-old way of doing quadratic equations. The second one is a more limited approach. It's a nice approach because it's quick and easy, but it only works in certain cases. That's the square root method. And then the last one is like the skeleton key of quadratic equations. That's the quadratic formula. Can't solve it with the first 2. Use the quadratic formula. There is a new way of solving quadratic equations, and I really like it. It's just I'm trying to figure out how the best way to teach it. I've been spending like almost, I don't know, 2 semesters or so trying to figure out the best way. So, but right now we're sticking with this. It's an interesting way of solving them, and it works for everything because it kind of uses quadratic formula, but it's hard to convey. Like it's a hard idea to convey to people. So that's why I'm not teaching it yet. But one day I'll figure it out. All right, so let's talk about what a quadratic equation is. So like I said, the highest degree of any variable is 2. This is going to be the basic form. We got ax squared plus bx plus c is equal to 0. Doesn't have to be an x. It could be whatever variable you want. But what we need are a, b, and c to be real numbers. And just like before, we want a to not equal 0. If a was 0, then it would just be a linear equation. B and C can be 0. No problem with that. So you may not have a B term, you may not have a C term, which actually will make it easier if one of those are missing or both of those. And so that's the basic form. Any questions on that? Pay attention to ABC. You may recognize it from when we did the AC method. It's the same. They're just using lowercase. But we're going to need those labels when we talk about factoring, because we're going to use the AC method and the quadratic form. All right, so let's hop into a problem. Oh, guess we got 2 problems. And there we go. And see what we can do. Anybody still copying that down? All right. It's in the notes, I believe in the textbook too. It looks like I just snipped it out of the textbook. All right, so to solve a quadratic equation by factoring, the first thing you want to do is get one side equal to 0. So if one side is not 0, you don't want to start factoring yet. So the first thing you want to do, get one side equal to 0. For this first problem, we're looking at x squared plus 6x is equal to 0. One side's already equal to 0. And I'll tell you why I want that after the next step. So now we want to look at this term here, the non-zero term, on the non-zero side, let's say that way. Can we factor that? Can we factor x squared plus 6x? Anybody think we can? Or what can we factor? Or how can we factor? We can take out x. Remember the first thing you want to do when you're factoring, see what you can take out. What's a common factor between all the things? And both of these terms have an x, so we could factor out an x. And we'll be left with x plus 6. Now the whole reason that factoring works when we're solving these quadratic equations is from something we learned earlier, but I really like it, so I'm going to bring it back up. It is a zero product property. And remember the zero product property, what that says is that if you have A times B is equal to 0, then either A is equal to 0 or B is equal to 0. And you can work from more terms than just 2. If you have 3 terms, any of the 3 could be equal to 0. 4. Any questions on that? So if we use that and apply it to what we have here, we have x times x plus 6 is equal to 0. That means that either x is equal to 0 or that's x plus 6 is equal to 0. Now, when I'm saying or, I mean either of those could be true or both of them could be true. I'm sorry. Chat windows in here. And what we end up with here is just two linear equations. This one's already solved for us. X is equal to 0. That's one solution. This one we just got to solve up. Subtract 6 from both sides. You get x is equal to -6. And so we would have two solutions. Once again, you got to check your domain. You don't have any domain issues with this one, right? No x in the denominator, no x under even root. Don't have any domain issues. And so we're good to go. You can check your answer as well. Plug them back in, see if they work out. Any questions on that? So let's talk about how these answers can be written. So there's a few different ways to write this. You may see different ones in my math lab. You could just say, well, x is equal to 0 or 6. X is equal to 0, 6. Sometimes they'll say they want you to write it as what's called a solution set. Anybody ever heard of that before? A set is just a group of objects, in this case numbers. And that solution set, I struggle with writing these. There'll be an opening brace, 0, 6, closing brace. I think my math lab will actually put the braces for you. You just got to type in the number. And the other way is what's called set builder notation, in which case they'll have the open brace, x, a vertical bar, x equals, and you put the 0 and 6 and close the brace. That vertical bar means where or such that. So that's read as the set of x's such that x is equal to 0 or 6. Oh, is it -6 the whole time? Yep. Sorry about that. It is -6. I didn't see my own negative. So that's probably the three ways you'll see it. Possibly, I can think of it. What do I have in here? Oh, in the notes I have it as the solution set. So this one here. Any questions on that? All right, so let's work through the second one together. I don't know if I have another one for us to try. I can make one up. All right. So here we have 2x squared is equal to x plus 3. So what's the first thing that we need to do? We get one side to 0. Yep. So the first thing we need to do is get one side equal to 0. How are we going to do that? Okay, so there's two options here, right? One option is we subtract the 2x squared, and neither of them is wrong, and we end up with 0 is equal to -2x squared plus x plus 3. The other option is what? We can also move the x and the 3, right? Subtract an x, subtract the 3, and we end up with, I'll just do it in a different color here. We end up with 2x squared minus x minus 3 is equal to 0. Both of these are equivalent to each other. There's no right or wrong here. But I would recommend, and we'll work it out this way just to see, is I like to keep that a term positive if possible, okay? It just makes factoring a little bit easier, but it's not wrong. long as you follow the rules, the math's not wrong. But let's keep trucking with this one right here, because I'd rather show you the hard way, right? If that's what you end up with. But the other way would be the same method. So we're looking at negative 2x squared plus x plus 3 is equal to 0. So that means we're ready to factor. Can we factor out a common term between the negative 2x squared plus x and plus 3? Is there a common term there? No, there's nothing. So what are we going to try? Well, we're going to try the AC method. Or whatever factoring method you prefer. This is just the one I teach. And so AC is going to be negative 2 times 3, which is negative 6. And my B term is just a positive 1. Right? If it's just a 1x, that means it's positive 1. And so that means I'm looking for numbers that multiply to be negative 6 and add to be positive 1. I use 6 a lot. What do you think it'd be? Negative 2 and 3. Yeah, that looks right. I don't have much room, so let's keep going right here. So now we're going to break up this B term with these terms, right? So we're going to have 0 is equal to negative 2x squared minus 2x plus 3x plus 3. So now we're going to do the factor by grouping. Look at this first pair here. What can I factor out of those two? What do they have in common? Let's do negative 2x, right? So we'll pull out our negative 2x. We'll be left with x plus 1. Oh, I left out an x here. Should be 3x. Make sure y'all put that x here. All right. Questions on that? Yeah.
We wanted to do the other one where it's not negative.
So if you factored out, if you did that, looks like it would be negative 3 and positive 2 would be the numbers that you choose. I can work it out that way after if you want.
But if it's a positive, no, never mind.
See it?
Yeah.
Yeah, right. Yeah, I mean, you should get the same answer in the end. Yeah. It's just taking a little different route. All right, any other questions? So we got that. So that means that I want to factor something out of the 3x plus 3 such that I end up with an x plus 1 as well. So what would that be? Looks like a positive 3, right? So we factor out a positive 3. We got our zeros there. So this term has an x plus 1. This one also has an x plus 1. We're going to pull out that x plus 1. And what's going to be left? Negative 2x plus 3. That's going to be our other term. And now we end up zero product property again, right? This times this is equal to 0. So therefore, either x plus 1 is equal to 0 or negative 2x plus 3 is equal to 0. which is going to give me a solution set. Well, let's solve it out. Here you get x is equal to -1. Here we would get x is equal to 3, so -3 would be what, 3/2? And so my solution set is going to be -1 on the 3/2. The order that you write the answers in the solution set does not matter. Order doesn't matter in sets. Any questions on that? No, I got it. Got it here. Oh, I'll check that out. All right, so I got. Anybody still copying anything down? Got a couple for y'all to try. Cause I don't think I have any more. No, those are gonna be square root method. Yeah. Let me copy anything. And so let's say 3x squared is equal to 3x, and x squared, let me check this real quick. Okay, yeah, is equal to x plus 2. That first one, oh, sorry. That first one is the one that you want to make sure you don't divide by x. Because you can, but it's going to get rid of the one solutions. I'll give you a few minutes. Try it out. If you got a question, raise your hand, let me know. There's a few different routes to go with this. The one that you want to avoid is don't divide by x. Okay. And the reason being is when you divide by x, it takes away the possibility of it being 0. I think I talked about that before, but I don't know if I could explain why. And I always say it because I see it a lot. I remember making that mistake myself when I was in school. All right, so first things first, we're gonna try to do. Did anybody divide by 3? That's the first question. Yeah. Okay. Yeah. I didn't think about that when I made the problem, but you could just divide by 3 and it gets rid of the 3. But let's say we're gonna follow what I said before. We're gonna move everything on one side, get it equal to 0. So we're gonna subtract 3x. So we'll have 3x squared minus 3x equal to 0. So dividing by 3 is a good route to go. So if you did see it, it's good. And we're gonna try to factor this up. Both my terms have a what? 3x, so we'll factor out a 3x. And we'll end up with what? X minus 1 here. And so we have 3 terms multiplied together, right? So 3 times x minus 1. I know that 3 can't equal 0, right? That means either x is going to equal 0 or x minus 1 is equal to 0. So that's one way to get rid of 3, is that way. And then this one's solved already. X is equal to 0. This one we're going to add 1 to both sides, and we'll get x is equal to 1. And so our solution set is going to be 0, 1. Well, the set containing 0, 1. Be the proper way to say it. Any questions on that? No? Yeah.
Is there always going to be like in a sense or always
Not necessarily. So the reason that these are 0 is because it's this form right here, where it's x squared and then an x term. If it's that, usually 0 is going to be one of the answers, because if x is 0, then both of these terms are going to be 0, and that's what's making it happen. Mm-hmm.
So why are you putting the? I don't understand. Like I get it, but I also don't get why you put in the x minus 1 in the middle.
Right here.
Yes.
Okay, so all I'm doing is this term has a 3x, right? This term also has a 3x. So I'm factoring that out. This, when I take out the 3x, what's left over? Just an x. What's left over from this one? A negative.
Okay.
Does that make sense? Yeah? Okay. Any other questions? So if you divided by the 3, you would pull out an x, right? And then you would have the x minus 1.
I think I only got an X in that thing.
Okay. Oh, did I not leave myself enough room or? Oh, there it goes. All right, let's try this one. 10x squared is equal to x minus, oh, sorry, let's try it again. 10x squared is equal to x plus 2. So this one I can't divide by something and do anything with it. So the first thing I'm going to do is try to get equal to 0 to both on one side. And so we're going to subtract x and subtract 2 from both sides will be the best plan there. And so we'll end up with 10x squared minus x minus 2 is equal to 0. Hopefully this one works out because I made it real quick, but it should. All right, so first thing we look for, common term. There is a common term between these two, and there's a common term between these two, but there's no common term between all three. So we can't factor anything out as a common term. So next thing we're going to look at is our AC method. AC is going to be 10 times negative 2 is negative 20. And my B term is negative 1. Notice that the sign comes with it, right? So we want numbers that multiply to be negative 20 and add to be negative 1. So what are some good candidates there?
Negative 5 and 4.
Negative 5 and 4, yep. So 5, 4, and yep, 5 needs to be negative. So now we're going to rewrite our equation. So we're going to split that negative x term using these coefficients here. So we're going to have 10x squared. I'm going to write it in blue so you can see it. Minus 5x plus, yeah, fix that. All right. Plus 4x minus 2 equal to 0. And if you write those in the opposite order, like you did 10x squared plus 4x minus 5x minus 2, it should still work out. I've had students in the past get really like caught up on which one they write first. It really doesn't matter. All right. So now we're going to look at our first pair here. 10x squared minus 5x. What can we factor out of those? What do they have in common? I know. 5x. Yep. And so what's going to be left over inside? That'll be 2x minus 1. Now I want, any questions on that? Now I want to factor something out of the 4x minus 2, the positive 4x minus 2, such that I get 2x minus 1. What can I factor out to get that? A positive 2, yep. And so now, 2x minus 1, 2x minus 1. We're going to pull that out. What's left over? 5x plus a 2. And those are equal to 0. Questions there? All right, so now zero product property, right? This times this is equal to 0. That allows us to say that, well, either 2x minus 1 is equal to 0, or 5x plus 2 is equal to 0. And then we just solve those. So let's add 1 to both sides. 2x is equal to positive 1 divided by 2. X is equal to 1/2. Subtract 2 from both sides. 5x is equal to negative 2 divided by 5. And x is equal to negative 2/5. And so my solution set, I'll write that in black, is going to be 1/2 negative 2/5. Or the set containing 1/2 negative 2/5. And y'all can't see it because I put it under the chat. Questions on that? No? Y'all getting it? Cool. Factor is probably the way you're more familiar with. There are some people out there. Well, we'll talk about that later. All right, any questions? So the last method I want to talk about today, we'll probably do the quadratic tomorrow, quadratic formula, is the square root method. If you can do the square root method, it's the quickest and easiest way to solve a quadratic equation. You do need to be careful because there are some things you need to do when you do it. And it has to be a specific form before you do it. So there are some criteria. You can still use the other methods to solve some of these. We'll talk about that. So the square root method, what it's saying is that if x squared is equal to p, and p has to be greater than or equal to 0, so it has to be non-negative. If it's negative, this will have no solution, honestly. Then x will equal the square root of p or negative the square root. And I'll start y'all off with an example other than this one I have right here. We'll talk about that after. All it's saying is if you have something like x squared is equal to 25. What number squared equals 25? 5 or negative 5. Yeah, so that's what it's saying. So if you have x squared is equal to some positive, well, it doesn't have to be positive, non-negative number, you can take the square root of both sides, but on this side opposite the variable, you need to do plus or minus. And so this solution would be x is equal to plus or minus the square root of 25, which we know is plus or minus 5. So my solution set would be negative 5, positive 5. That's where the square root method comes from. It's really simple when you think about what it's doing, but it can become more complex. Any questions on that? So notice the form that it had to fit. You had to have x squared equal to some non-negative thing, right? What about this? If I have x squared is equal to 5. What number squared equals 5? Well, we don't know, but let's try the square root method on it. So if we have x squared is equal to 5, and we take the square root of both sides here, the side opposite the variable is going to be plus or minus. Can we take the square root of 5? Can we evaluate the square root of 5? We can, we'll just get like a decimal, right? And so this means that it's just going to be x is equal to plus or minus the square root of 5. So my solution set is just going to be the set containing negative square root of 5, positive square root of 5. Those types of problems, you can't really solve by factor. Because how are you going to factor x squared minus 5 is equal to 0? You're not going to do it. The first one we did, you could solve by factor. Any questions on that? All right, let's take it a step further. I believe the next one here. Here we got x minus 2, that whole term is squared, is equal to 16. So it's not just an x squared, but it's a term containing an x that is squared, and it's equal to a non-negative number. So that means we can still apply the square root method here. So if you have x minus 2 squared is equal to 16, we're going to apply the square root method. So we'll take the square root of both sides. The side opposite the variable, remember, is plus or minus the square root of 16. And so what we end up with is x minus 2 is equal to plus or minus, what's the square root of 16? 4. Questions on that? Are we done? No, what we end up with is two linear equations. We end up with x minus 2 could be equal to positive 4, or, right here, x minus 2 could equal negative 4. And then we solve both of those. So if I add 2, I'll get x is equal to 6. And on the other one, if I add 2, I get x is equal to negative 2. So the solution set for that one would be, lost my number right there, is 6. So that is another one you don't have to use the square root method on. You could expand the x minus 2 squared using like FOIL, right? You get x squared minus 4x plus 4 is equal to 16. Make one side equal to 0 and then factor it. You can do it. It's a lot more work than what we just did there. Any questions on that? Oh my God. Okay. Let me make up somebody. I need a new sheet. Let's start off with you. Oh no, that's bad. Sorry. So let's say we got x squared is equal to, let's just do 7. Let's do x plus 3 squared is equal to negative 0.5, and x plus 1 squared is equal to 64. So the first one, x squared is equal to 7. It's just an x squared on one side, non-negative on the other side. So all we gotta do, take the square root of both sides. Remember plus or minus there. So we're gonna get that x is equal to plus or minus square root of 7. And so my solution set will be negative square root of 7, positive square root of 7. Since we can't take the square root of 7. Any questions on that? Yeah.
Did you ever leave it like plus or minus the square root of 7? Like for the answer, or do you want us to put it
written like this?
Yeah.
I don't know if my math lab allows you to put this. Like in class, yeah. But for the quizzes and the tests and the homework, you may have to write it out as two terms.
Okay.
I mean, either are mathematically correct ways to write it. Just depends what they instructions are. Any other questions? All right, let's look at the second one. So this time we have a term of x. X plus 3 squared is equal to negative 25. So can we take the square root, make this plus or minus square root of negative 25? What do y'all think? Well, if we do it, and we get x plus 3 is equal to plus or minus square root of negative 25, the issue that happens is when you take the square root of a negative, it's going to be an imaginary number, right? And so we're not dealing with that in this class, so this is going to be no real solution. There is a solution, but it involves complex numbers. We're not doing it. I'm just going to close this right now. Questions on that? So if it is a term of x squared equal to a negative, you know it's going to be no solution right away. It could be 0, that's fine. It could be positive, that's fine too. If it's negative, that's when you have no real solution. Questions on that? All right. Probably see one like that in the whole, I would guess. This time we have a term of x plus 1 squared equal to 64, but this time it's a positive there. So we're going to do the square root of both sides, make sure this is plus or minus square root of 64. So this is going to be x plus 1 is equal to plus or minus the square root of 64 is what? 8. Wow, sorry. My hand gave up halfway through that 8. There we go. And so this is going to become two separate equations. Either x plus 1 is equal to positive 8 or x plus 1 is equal to negative 8. Solve both of these. You get x is equal to 7. X is equal to negative 9. And so our solution set there will contain 7